All right, so today we will take a look at, I don't know, I guess some programming basics. A lot of it's going to be review, but we're just going to kind of hammer home certain points. Okay, so one thing I want to cover is just like shortcuts and stuff to just make you a little bit faster at working in RStudio. Sometimes students will come visit me during office hours, and then I'll ask them to run a piece of code or something, and then they're doing stuff, and it's just like trying to explain to your parents how to use their smartphone or something, and it's like frustrating, right? You're just like, oh my gosh, why does it take you so long? And don't worry, I'm not. You guys are learning, okay, and so I'm happy to help all of you, but here's just a few things that I think will make you a little bit faster, right? I saw a bunch of questions on CampusWare. There's probably at least 5 of these questions talking about how the file wouldn't load, right? The month names text file, no such file or directory found or something like that. 99% sure that's a working directory issue, okay? So one thing I do is in the menus, whenever I start working on a file, I'll go to session, set working directory to source file location. Because in general, I keep the file that I'm working on and the files that it's going to reference in the same folder, okay? But, if you got something else set up, you can do something different. But if you do this, this will fix a lot of working directory issues. You can always set the working directory manually. Excuse me. This requires you to know the path to your directory. And if you're on a Windows machine, you've got to put in forward slashes and stuff, or double backslashes. So it's a tiny bit annoying, but this is what Windows does. Okay, so that's setting your working directory. Another thing that happens is as you work, your environment in R starts to fill up with a bunch of stuff. Right now I don't have anything in here, okay? And people will often I'll see stuff like this posted on CampusWire as well, where they'll say, my code works in R. When I run the code in R, it works, but when I try to knit it, I get an error, and the error is object not found or something like this, right? Object, X not found or something. That happens when object X is defined in your environment, but you actually don't create the object in your code, okay? Because when you click knit in R, it always starts off with a completely empty environment, and it goes through. And if your code says, do this to X, but in your code for knitting, you never actually created that object X, that's when you're going to get that error, object X not found, okay? And so one thing that helps is that when you're troubleshooting, you should just clear out your environment. You can say, all right, let's start my code with the same environment that R is going to have when it knits, okay? You clear out your environment, then you go through your code line by line, and you should also encounter that same error where it says X not found, okay? The issue of, people say it works in R, but then I can't knit it. It's often because your environment in R is different from a blank one when you start the code, okay? So anyway, click the broom icon, that clears everything out, okay? Another one you can do is RM. RM list will delete objects one at a time. You name it. You can also just say RM list equals ls, and that will delete everything out from your environment as well. Okay. And then, so if I do X is 1 through 10 or something like this, another way you can delete items is you click the little check mark here. You have to switch to, I think, grid mode. Okay. Here you can't delete the items, or can you? Yeah, you cannot. Okay. So you can switch to like grid mode, click the X, and then delete that one object. Okay. Okay. Here's another recommendation. Okay. I strongly recommend that you do not save your workspace when you exit R, okay? When you start up R, you should always start off with a blank workspace, and that means when you exit R, don't save your current workspace, okay? This is going to force you to have good save habits, right? If you know that R never saves anything when you exit, you're going to save it, right? Save the files that you need. So you will explicitly save these things. And then, because what happens if you don't start off with an empty workspace, right? There's certain names that we use constantly, right? Like X and results and whatever, right? DF for data frames and stuff. And so you might be working on some kind of function that uses the variable X, the object X. And if X is already defined in your environment and you call it or something, it might do something that you don't want it to do because it's using the wrong input values. So always start off with an empty environment, okay? And part of starting off with an empty environment is never saving your environment when you exit. So, so what I like to do is I like to uncheck this button, restore R data into the workspace, and then save workspace to R data to never. Okay. You don't have to, but that's what I do. Okay. And then this is just what I said. All right. A couple shortcuts here. You guys all know about comments, right? You put the little hash mark and it turns everything to a comment. You can toggle comments very quickly. Toggle comments using Command-Shift-C or Control-Shift-C on your keyboard. You can comment out entire blocks of code. So rather than having to go and do pound on this line, pound on this line, and pound on this line, you can just highlight all three of these lines and hit Command-Shift-C or Control-Shift-C, and it will toggle them on or off, okay? It's very useful, especially when you are trying to you know, turn certain sections of your code on and off, right? Because I think that's a common thing we do. We write some code and we go, okay, wait, what if I turn this entire thing off? But you don't want actually want to like delete it or something. So you want to comment that out. But it might be like 10 lines, and instead of having to write pound or hash instead of in front of every line, you can just highlight all those lines, Command-Shift-C or Control-Shift-C. It's very useful. Okay. Scripts, right? So for your homework, you have to write some scripts. In general, writing scripts is very good, right? You can create a new script by doing Command or Control-Shift-N. That will create a new script. And then from your script, and also with an RMD file, you can just execute lines of code by hitting Command or Control-Enter, right? So you just, so here's one block of code. I can just hit Control-Enter, and it's going to run it. Apparently, my environment's clear, so it's running into errors here. But you can just kind of highlight the lines of code that you want and hit Control-Enter, and that will run one line of code at a time down your script. Okay. Another thing you can do, all right, is you can hit Control-S to save your script, but you can also hit Control-Shift-S, and that will save your script and immediately source it into R, right? So, so if you want to like try out some code, this is a quick shortcut. You know, you make your edits, Control-Shift-S will save it and immediately source it into R, so you don't have to like copy and paste it or you know, manually source it yourself. So this is a nice handy thing for your scripts. Okay. Other useful shortcuts: clearing the console with Control-L. So as you work in your console, it gets full of stuff, and you just want to kind of clear out your space. Control-L clears the screen. That's nice. Okay. You can restart your R session. That's Command or Control-Shift-F10. Okay. And that will restart R. Okay. And so that's going to clear out any libraries or packages that you've loaded, clear out any things, right? You can always go to Shift session and then restart R here. Okay. But Command-Shift-L, right? And then as you're working on an RMD file, Command-Shift-K or Control-Shift-K will knit knit your file. So, I mean, it's not hard to click the knit button here, but you can also hit Control or Command Shift K to knit it. All right. And again, just like anything else, the more you use these things, the more like second nature it will become to you, right? So it's like driving. I don't know if you guys drive, but probably the very first time you sat behind the wheel, it was very awkward, and you felt very uncomfortable. Okay, and then when you start off programming, it's awkward and uncomfortable. Okay, but then the more you do it, you get better, and it becomes natural, where you can drive home without really thinking about it. Okay. All right, let's talk about some flow control, right? This is how we control how our scripts work. All right. Okay, I think you guys are familiar with these things. Logical operators, you got the or and the and, the not, and the exclusive or. These ones are all vectorized, right? Vectorized, that means you can put in a vector x, a vector y, okay? Logical vector x, logical vector y, and it goes element-wise, compares the first elements and then the second elements and so on, and it's going to produce a logical vector of output, okay? These ones, the double or, the double and, those are non-vectorized, okay? If you give it a logical vector more than one value, it's only going to look at the first value, all right? And so these are not vectorized. We use these, the double or, the double and, in if statements. If statements can only accept one logical value, okay? And so so the non-vector version is preferred for if clauses, okay? Whereas the vectorized ones are for anything else, right? Element-wise things, right? We've got the not operator, the exclamation point, and that's also vectorized. If you give it anything that's numeric, it's going to coerce everything into logical, and the rule there is if it's 0, it becomes false. Anything that's not 0, right, even negative numbers, decimals and stuff, those all get coerced to true. All right, so here's a couple questions. How do these logical operators with missing values, right? So what is true or NA? True and NA, false or NA, and false and NA. So go ahead and think of your answers to these things. Write these down. All right, what do you guys get? True or NA? True. True and NA. NA. False or NA? NA. False and NA. False. Oh, good job, you guys. All right. Okay, so this is exactly that. I've got true, true, false, false, NA, 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 and then false, true, true, false, NA, and we see exactly that, right? So the first four where both are defined, we get exactly what we expect, right? If one of them's true, we get true. It's only when both of them are false that X or Y returns false. NA or true returns true. NA or false, and NA or NA will return NA, okay? Whereas over here with the and, we get exactly what you guys said. You guys are great. The double or only looks at the first element, so it's basically true or false, and that's going to be true. And then double and is only the first element, basically true and false gives us false. All right, here we've got exclusive or. Exclusive or is like or, except that when exclusive or is, when you got true, exclusive or true, that returns false. So one has to be true and one has to be false. Okay, so we get true or false is true, true and true is false, false and false is true. I mean, false and false is false, and false and true is true. Okay, and then if one of those things is missing, if either of those are undefined, it's going to return back missing. We've got these generalized versions, any and all. So any is kind of like a generalization of OR. Okay, so if you got all trues, are any of these values true? That gives us true. Here I've got a mix. I got true, true, false. Are any of those values true? That's true. And then are any of the values in W, which is false, 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 are any of those values true? That's false. Okay. The all is the generalization of the and. So are all the values in U true? That is true. Are all the values in V true? That's false. Are all the values in W false? Are all the values in W true? And that is false. Okay. So that's any and all. All right. Think about this. So here are the rules that we're going to go by. Okay. If we've got a logical zero, a length 0 logical vector, what we want is that any with the length 0 vector and V should be the same thing as any V. And all with the logical zero length logical vector with V should produce the same result as all of V. Okay. So with this in mind, okay, and don't cheat, don't type any logical zero into R, okay? And I want you guys to think this through. If these are the rules that we're going off of, what does any logical zero return and what does all logical zero return? Okay, so keep that in mind. And what would this return? Okay, so don't go into R and type this out and cheat. Whatever, this is just your learning exercise. I want you guys to think about this, right? So if we get a length 0 vector, what happens? All right. Did you guys come up with an answer? So any on a length 0 vector will produce nobody? All right, well, let's think this through, okay? Okay, so any on a length 0 vector is false. So let's see why, okay? So here I've got U, V, and W, right? So any on U returns true, any on V returns true, and any on W returns false, okay? So here I've got X as a length 0 vector, and any on X returns false, all right? So the reason why for is that if I combine the false into U, my question of are any of the values in X plus the false, okay? U is now I got true, 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 false. Are any of those values true? That returns true. It's the same, okay? Are any in V and false true? That also remains true. And W, okay, when I combine this here, are any of the values true? That remains false. If this statement, logical zero, any on a logical zero returns true, this statement would change, right? So W by itself is all falses, and so the answer is false. But if this returned a true, and I asked, are any of X and W true, then that's going to become true. So that's why any on a logical zero returns false. Okay, and the same logic applies when we're talking about all. Okay, in these cases, are all of these true? Okay, logical zero on all will return true. So that this first statement, are all the values in U true? That is true. And if I add a length 0 vector, the answer needs to be true. If this returned false, and I add it to X, okay, add the length 0 vector to X, that would change this to false. Okay. By having it return true, it's not going to affect any of these things, right? Because there's already a false in here, so adding another true, and I ask the question all, it's still going to return false. So that's no problem there. All right, we've got some comparison statements, right? So this we've got numeric vector values or whatever. You can ask these. These are all vectorized, x greater than, less than y, greater than or equal to, are they equal to, not equal to. You even have an in operator, right? Is this element in this other vector? And that's all vectorized, so that's great. All right, let's talk about if statements, right? So we execute conditional statements using if, right? If expects a length 1 vector, length 1 logical vector. If it's not logical, it'll coerce it to logical. And if it's not length 1, you get back a warning. Okay? And if you give it an NA, it's going to give you an error. Okay? And then the code that's associated with the if statement, you generally put in curly braces, but if you only have one line of code, you technically don't even need the curly braces. All right, so very, very simple, doing exactly what we expect it to do. X is this numeric vector, 1, 3, and here's our statement that's going to return a logical value is 1 in the vector x, and that's true. So we say if 1 is in x, print hello, and so when it executes, this is true, this statement gets executed, and it prints hello onto the screen. All right, here, x is this numeric vector, and I say is x greater than or equal to 2. This returns false, then true, okay? And so I give this logical vector of length 2, and so it says if, and then we get this vector of length 2, so we get back a warning, right? So it says, you've given me a logical vector, it's longer than length 1, so you're only going to use the first element. So the first element here is false, which means this code inside this code bracket does not get executed. So it just gives us the warning, and then it doesn't execute this code, and it's done. All right. If I just change it around, okay, same thing. It still gives us the same warning, okay, that we've given it a logical vector greater than length 1. And then because the first element is true, it does execute this line of code, and it prints out the statement hello. Hello again, I guess. All right. So one way to remedy this is if you got this logical statement, maybe a logical vector, maybe you want to throw it into a vector like any or a vector like all. Okay, and that's going to take a longer length logical vector and return just a single value. Okay, and so in this case, if we ask, are any of the values greater than 2? That's true. And so we got this if statement is true, and so it's going to evaluate this this line of code. If you give the NA if statement an NA, it's going to error out. Okay, and this is a very common message here. Okay, the error that you encounter. So here I've got x is defined as the numeric vector 1 through 3. And then I just ask, is x number 5, subset 5, greater than or equal to 2? X subset 5 is a missing value, right? X subset 5, because it's only a length 3 vector, is going to return NA. So it's asking, is if NA greater than or equal to 2? Well, the answer to that is NA. So we've got if NA, and then it doesn't know what to do, okay? Because the if statement requires, if it's true, it's going to do it. And if it's false, don't do it, right? But then the answer is, I don't know if it's true or false. And so it doesn't know if it should or if it shouldn't. Because those are the only two options. There's no like default in that, like if you don't know what to do, you have to make a decision. It's in a situation where you can't make a decision. So anyway, this statement, missing value where true false needed, is a very, very common error, right? So one of the difficulties of R, or learning R, is that you get these error messages and you don't know what they mean, okay? But there's certain error messages that you encounter that will be very, very common, and you can, if you're aware of these things, you can fix your problems, right? So no such file or directory located or something, that's probably a working directory issue, okay? object not found, okay, just means you didn't create the object, or you're calling something, right? Subscript out of bounds means you're either trying to subset your matrix or list using a value that doesn't exist, or a value that's no good, okay? And this one, missing value or true false needed, almost certainly means you have an if statement where you've got an NA, okay? And so what that means is you're gonna have to go through your code, look at your if statement, and say, why am I getting an NA in this if statement? And maybe it means you just put in the wrong index, okay? And the index is referring to spot 5, and you shouldn't be referring to spot 5, okay? So these are the kinds of things that will help you debug your code and make you a better programmer, okay? Every time you encounter an error, take note of the error that you've encountered, right? Nobody writes bug-free code the first time around, unless the program is hello world, okay? Anything that's like over 20 lines of code, you're likely not going to get it right the first time around. So being familiar with the error messages and being able to figure out what you've done wrong and where to look is very helpful, okay? All right, let's talk about nesting these conditional statements. So you got if, and else if, and else. The else only gets looked at when the if statement is false, okay? So when the if statement is false, then it skips the associated code, goes to the else statement, and then here we've got an else if, and it will investigate that, right? So you got x is 3, x less than 0, that's false, so it skips this, comes here, and it comes to, if x is greater than 0, say it's positive, and so we get positive, right? Here I've got x is 0, this is false, so it skips that. Then it goes to the else if, x greater than 0 is also false because 0 is not greater than 0, so it skips that, and then it runs the last thing, the else, and it prints out 0. Here I've got x is greater than 3, and this statement, if x is greater than 0, that is true, okay, so it's going to print positive, and because it's true, it skips all of these else statements, okay? So this line is, if x is greater than 1, this is technically true, but it will never be evaluated, okay? It will never be evaluated because, well, not never be evaluated, but it will only get evaluated if this statement is false, okay? So if x greater than 0 is false, then it will come and ask, is x greater than 1? And so this line will never get executed because there's no situation where this is true but this is false, okay? So, so this just gets skipped and it just prints positive. It's not going to go down, right? If I wanted both positive and bigger than 1 executed, what do I have to do to my code? So if I want, you know, x is 3 and I want it to print out positive and I want it to print out bigger than 1. I really only need to make one change to it. What do I have to do? Yeah.
Bring that print bigger than 1 inside the first statement.
But that's not going to be correct, right? If I put bigger than 1 inside the x greater than 0 and I put in like 0.2, I just get rid of I just delete this else and I put if on a new line, okay? And so it's going to execute the if greater than x greater than 0. It's going to print positive, okay? And then because there's no else, it's also going to look at this line and say, oh, if x is greater than 1, print then that's going to be correct, right? Otherwise, I need to kind of move this else statement back up to the greater than 0, but you know, I would get rid of the else and move the if statement to a new line, right? So it's going to execute this if, evaluate this if statement, and then evaluate the following if statement. All right. So sometimes you want the result. You want to do an if statement and then save the results or something, or do some kind of evaluation there. Okay. One thing that's very handy is using the if-else function. The if-else function, probably one of its best features is that it is vectorized, okay? An if statement is not vectorized. If statement can only look at one logical value at a time. And so if you want to, like, if you have a whole bunch of values of x and a whole bunch of values of y, okay, and you want to kind of compare these things or something, you got to say, like, okay, look at the first state. You're going to have to build some kind of loop or some kind of operation where you're going to look at the first elements, throw it into your if statement, then look at the second elements, throw it into your if statement, and things like that. The if-else function is vectorized, so you can have an entire vector of x values and just say, like, and just figure out which ones are equal to 5 and which ones are not, okay? All right, let's talk about loops, okay? So the for loop is probably your easiest loop to deal with. I'm pretty sure you guys are familiar with this. And basically, a for loop, you give it any vector, and R is going to do the operation inside the loop for every element in that vector, right? So here's just a common thing. We just say x is the vector 1 through 10, and then print out cat x squared, right? In your homework, you have to ask, answer what's the difference between print and cat. And so, one thing to note is cat doesn't produce that square bracket 1, things like that. It just outputs stuff to the screen, okay? But anyway, so this is what we get, right? For 1 through 10, print out cat x squared and gives us squared values up to 100, okay? Here, the for loop can go over any vector. This is probably our most common thing, is we expect x to go through, the for loop to go through some vector of integers, but you're not required that it go through a vector of integers, okay? So here I've got a list. A list is technically a vector, right? So I've got a list with 3 elements, 1 through 3, the integer vector 1, 2, 3, a character vector of A through whatever, the 7th letter, and then a logical vector of true, false. And then I'm going to say for each element, for y in the list, print out or cat the length of y. So it goes through, it does it for the integer vector 1 through 3 and says the length of that is 3. Then it goes through to the next element in the list, and it says, okay, you got this character vector of length 7, and its length is 7. You got this logical vector with 2 values in it, and so its length is 2. So it can go through anything. It doesn't have to be like for y, x in 1 through 100 or something like that. All right, here's just another example. You can load up library data sets, and there's a vector called state.name, and it's got all the state names, right? So the first 5 states in alphabetical order: Alabama, Alaska, Arizona, Arkansas, California. And here we can just say for each state in this character vector, cat, the state, the character value, okay, has, and then the number of characters in it, and then letters in it, and a new line character. So we get Alabama has 7 letters in it, Alaska has 6 letters in it, so on and so forth. Okay, so we're just going through some vector, and we do the same thing for each operation in the vector. All right. When you run a loop and you want to kind of store its results, in general, it's best if you create the object where you want to store it, and then inserting it into that location, right? So here, I'm going up to 10 to the 8th, which is like 100 million, right? And what I'm going to do is, for each element, I'm going to time this, but I'm going to go for 1 through 100 million, square that value, and store it into results subset x, okay? This is the best practice in that I've created results, and I've said, make it length 100 million, okay? So I've created a vector of length 100 million already, and it's full of missing values, okay? And then I go through, and I'm going to assign, the first element to the first position, second value to the second position, and so on and so forth. Okay. This is very, very similar on the next line of code, or next slide. I've got almost exactly the same, but my first line is just I initialize it to just the value 0. Okay, so I initialize it to a type double vector. Okay, and this part is exactly the same, but what happens now is that we notice this takes a lot longer. This takes 51 seconds. This only took 13 seconds. Okay. The reason why this thing takes the exact a little bit longer, even though this part's the exact same kind of code, is that each iteration requires that this vector be resized. Okay. So initially the vector is size 1, and then after 2 iterations, it's got to resize it to be length 2, and the next operation's got to resize it to be length 3. And so that just requires a little bit more overhead in R to do. Okay. The next one is the worst method, and it's the slowest. Okay. And so what you're going to see is that this one I ran through 100 million. I'll probably redo this with not such a big number, but on the next one I think I only go to 100,000. Okay. So it's 1/1000th the length. Okay. So we would expect it to take like 1/1000th of the time, but even though I'm only doing 1/1000th of the work, it takes about half the time of the slow method, right? And the reason for this, okay, is here I start off with an empty vector, and then I say, let's just kind of append that value, right? So we're going to take the current results and combine it with the new value, and then save it back into results, right? So I think this is a common thing that people do, and this is fine. It's fine to do this if you only have like maybe 1,000 values to append to. But if you're climbing up into the big numbers, so here I'm at 100,000, we can see it's significantly slowing things down, because every time, by the time I get to the end, I've got to copy like 90,000 values plus one new value into a new object, right? And then I've got 90,001 values plus a new thing into a new object, right? So I have to copy everything into a newly defined object. And so this is the slowest method. Sometimes this is the easiest because you don't have to, because you're not quite sure how long the output is going to be. And so you don't, this thing isn't as easy where you're going to like define how long the output should be ahead of time. This is best. If you know how long the output should be, you should define it, and it's going to be the fastest. But sometimes you don't know how long the output's going to be, so you use some kind of method like this, but it's going to be slowing you down. Yeah, question? That's a good question. So elapsed is how long it takes for you to see. Okay, so you type the thing in. So system time is a way for you to time a certain amount of code. All right, so it executes all of this code. It executes all of it, and then elapsed is basically from when you hit enter and when that stop sign goes away and you can start typing in new commands. Okay, so that's going to be elapsed. User is, I think user is how much your code runs, but then honestly, I'm not 100% sure the difference between user and system here. But yeah, question?
Is the NA or there, is that representing that there's just not known values for length vector?
Yeah, so it's saying repeat missing value 100 million times, okay? And basically I'm just saying, for now, I don't know what these answers are, but I will, okay? I'm gonna fill them in with the squared values, right? Actually, all of these is much better if you don't even do a loop and you just say 1 through 100 million, square it, okay? That's gonna be the best. But this is just an example of storing the results. Okay, if you know how many values you're going to have, define that vector of that length and then fill them in. Okay, if you don't, you can do this and resize. Okay, and this is going to be the slowest method where you're going to just kind of like copy and grow it that way. All right. There are worse things in life than having slow code, though. Okay, I think R is notorious for like. People will say like, don't make loops in R, okay? That's a common thing people say. It's okay. I want to say it's okay to make loops in R. Don't feel guilty if you're making loops in R, okay? But it just means your code's going to be running a little bit slower, right? you guys are statistics majors and not CS majors, okay? And so code efficiency is of a lower priority than data analysis accuracy, okay? It's more important that you are correct and you understand what you're doing than having efficient code. You can always optimize code later, but yeah, question?
If you're trying to update a vector of unknown length, you don't know how long it's going to be, without a loop, how would you do that?
Wait. So without a loop, what are your inputs?
Just like say like
okay. So something has to be defined somewhere along the way, and so I don't know if I can answer your question directly because I think there's a little bit too many unknowns right now if you're just saying without a loop. So I'll talk about vectorizing your code in a little bit. I don't know if I address your question specifically, but generally, yeah, if you don't know the length of your output, you probably have to use a loop somewhere, okay, until like a certain condition is met, right? Okay. We've got while loops, right? So for example, like when you do your prime factorization problem, okay, you don't know how many prime factors there's going to be, right? Like I give you the number 194 or something, and I say find all the prime factors, right? You can't do this. You can't say, all right, I'm going to start off with a vector because I know exactly how many prime factors there are. So this is not a method that's available to you, okay? You can do this, or you can do this, but this is going to be the slowest. But, you know, prime factors of, you're not going to have more than like 8 numbers in your prime factor thing. So, you know, it's not too terrible, right? Okay. While loops. You keep doing something until the while statement becomes false, right? All right, so here's a question. So I started off with I is 1, and then I'm asking for a result of 10 or something. Okay, and we're going to go from I to I, we're going to enter I squared. And I update I to I plus 1. Okay, so at the end of the loop, what is the value of I? Is it 9, 10, 11, 12? What do you guys think? All right. Well, let's think about this, right? So at this number, 100 was produced when I is 10, right? So I got to be 10, while 10 is less than or equal to 10. This is still true. It takes 10 squared, and it's going to store 100 into the 10th position in results. Okay. Then it goes 10 is 10 plus 1, or I is 10 plus 1, so I becomes 11. Then it comes back around here, and it says while 11 is less than 10. This is false, so it stops the loop, and it quits. Okay, so it prints out the results here, and then I takes on the value 11. Okay. Here's the repeat loop. Okay, the repeat loop is kind of like is very similar to a while loop, except the condition, there's no condition up here. Repeat just keeps running the code inside forever. Okay. And so repeat needs to have a break statement. Okay, a break statement says quit the loop. Okay, stop whatever you stop the loop, quit the loop. And so here, similar kind of thing. When I is greater than 10, then it quits the loop, and we get this. It stops. Okay. So I is also going to be 11, and that's what we get. Okay. All right, so here's a question. Here's so we've got the words break and next. Break just stops the loop. Okay, so we're going to go for I in 1 through 10, and we're going to say if I is divisible by 2, that is, if I mod 2 equals 0, then quit the loop. Okay, and if you haven't quit the loop, then cat I to the screen. So if we run this code, what is this going to output? Is going to output 1. Okay, I is 1. It runs through the code. It outputs 1. Then it goes to 2. For 2, it this is true, and so it breaks, and it stops, and that's the end of the story. Okay, so we just get 1. All right. Same thing. I replaced break with next. Okay, so it starts off with 1. It outputs 1 to the screen. It goes through 2. When it hits next, it no longer executes any more code and immediately goes to the next iteration of the loop. So at 2, it hits this, it hits next, and immediately goes to 3. It doesn't outdo the cat, okay? For 3, this is not true, so it evaluates this and it will output 3. And then it goes to 4 naturally, okay, because it hit the end of the code and the bracket. Goes to 4, this is true, so it hits next, okay? And so this is going to output all the odd numbers, okay? Because when it's even, it hits next and doesn't outrun the cat statement. All right, here's a couple things, right? So you've got sequence length and sequence along, okay? So let me just kind of skip forward. These lines of code look very similar, right? So if I've got L is a list of length 3, I can just do 1 colon length of L, and it's going to go 1, 2, 3, okay? And if I do sequence along L, it also produces 1, 2, 3, or I can do sequence length L, which is 3, sequence length 3 is going to produce 1, 2, 3, okay? No issues there, okay? But if the vector is of length 0, 1 colon length L is going to produce the vector 1, 0, okay? And this is going to cause problems in your code. So if you have something where, print out the length of that list element, it's going to do L double bracket 1, right? Because it's going to run through here. It's going to, for X and 1 colon length L, 1 colon length L is 1, 0, so it's going to try to do L double bracket 1, which doesn't exist, and you get this error, subscript out of bounds, okay? So to avoid situations like this, where you might have a vector of length 0, you can use sequence along, okay? So sequence along is different from 1 through length L, because sequence along a 0 length vector is going to be a 0 length integer vector, okay? And so when you try to run this code for X in some length 0 integer vector, there's nothing to evaluate, so you run into no issues here, okay? This never gets evaluated because this for loop just says for nothing, I'm not going to do anything, okay? All right, I've got a couple slides on just vectorizing code. Let me just kind of flip through them quickly. There's 2 operations, row sums and column sums, that operate on matrices, and they are very, very, very fast. If you can use row sums and column sums, try to, okay? So for example, I create this big matrix, 1 million rows, 100 columns, and I'm trying to find the mean of each row, okay? The mean of each row, if I subset down to the row, it takes about 10 seconds. Another option is I can take the apply function, apply it to margin 1, apply the mean function. That takes about 15 seconds, okay? Look how fast row sums work, right? I can take each row, sum it, and divide by the number of columns. That's another way of calculating the mean, okay? This takes 0.31 seconds, okay? It's very fast. If you can think of a way to incorporate row sums or column sums in your calculations, it's going to be better, right? And we get the same results in all of these things. Okay, and then I talked about the if-else statement. It's way faster, okay? So this takes 2 seconds. This takes 0.07 seconds. I'll expand on this, but we'll end there. We'll see you guys on Wednesday. I'm working on homework assignment 2. I'm writing that up. You can expect to see that posted soon.